In the world of industrial automation, annual conferences provide invaluable insights into the latest advancements and trends. This year's event was particularly remarkable, showcasing continuous evolution and improvement in industrial automation technologies. At the heart of these advancements are programmable logic controllers, or PLCs, which are crucial in controlling machinery and processes in manufacturing environments. The integration of advanced software platforms has further enhanced their capabilities, enabling more complex and efficient automation solutions. Modern software tools now offer intuitive drag-and-drop functionalities and enhanced simulation capabilities, allowing engineers to design and test their programs in a virtual environment before real-world deployment. Another significant trend is the move towards more integrated and interconnected systems, with the industrial Internet of Things gaining traction. This connectivity enhances efficiency and responsiveness of industrial processes. Security is also a critical concern, with modern PLC programming environments incorporating robust security features to protect against cyber threats. Continuous training and education are essential to keep pace with these technological advancements. As we dive deeper, you'll understand the critical role of PLCs in industrial automation and the need for their continuous evolution. Modern PLC programming environments have undergone significant transformations, making them more intuitive and efficient. Picture this: you're now able to design automation systems with drag-and-drop functionality, drastically reducing the time and effort required. These tools allow you to simulate your programs in a virtual environment, ensuring everything works flawlessly before real-world deployment. The integration of simulation features means you can catch errors early, saving both time and resources. Moreover, the latest environments offer enhanced debugging tools, providing real-time insights into your program's performance. This level of detail ensures you can fine-tune your automation systems to perfection. Now, let's delve into the initial configuration of PLC systems. First, you need to establish communication with the PLC. This involves setting the correct IP address and subnet mask. Ensure the PLC's IP address is unique within your network. Next, configure the communication protocol, typically Modbus or Ethernet/IP. Set the baud rate to 19,200 for legacy devices or 9,600 for newer models. Don't forget to enable the Keep Alive setting to maintain the connection. For security, use a strong password and enable encryption if available. This setup ensures a stable and secure connection for your PLC programming environment. Now, let's dive into the core of PLC programming, executing PLC programs. Imagine your PLC as the brain of your industrial automation system. To make it work, you need to write code logic and wire it correctly. Start by opening your PLC programming software. Navigate to the Program tab and create a new ladder logic program. Each rung in your ladder represents a logical statement. For instance, if you want a motor to start when a switch is closed, you'd use a normally open contact representing the switch and a coil representing the motor. Connect them in series. Remember, the flow of logic in ladder logic is from left to right, top to bottom. This is your basic setup. But there's more. To ensure your program runs smoothly, double-check your wiring against the physical setup. Mismatched connections can lead to errors. And here's a pro tip: always comment your code. It might seem trivial now, but when you revisit this program months later, those comments will be invaluable. Now, let's dive into the integration of PLCs with the Industrial Internet of Things, or IoT. This integration is crucial for real-time data collection, which enhances the efficiency and responsiveness of industrial processes. Imagine your PLCs as the central nervous system of your factory, constantly collecting and processing data from various sensors and devices. To achieve this, you need to set up a robust network architecture. Begin by configuring your PLC to communicate via OPC UA, a standard protocol for IoT. Ensure your PLC's IP address is static to maintain consistent communication. Next, deploy edge computing devices close to your machinery to reduce latency. Use MQTT for lightweight messaging between devices. Remember, the key to successful IoT integration is not just collecting data, but analyzing it in real time to make informed decisions. And here's why that matters. As we delve deeper into the integration of PLCs with it, the importance of security becomes paramount. Modern PLC programming environments are now embedding robust security features to combat the rising threat of cyber attacks. Imagine your PLC as a fortress. You wouldn't leave the gates open, would you? That's why encryption is critical. Use ISE 256 for data at rest and TLS 2 for data in transit. Secure communication protocols like OPC UA ensure that only authenticated devices can interact with your PLC. Regularly update your firmware to patch vulnerabilities. Consider this: a single outdated device can be the weak link in your entire system. And here's a pro tip: implement a zero-trust architecture where every device, regardless of its location, must be verified before accessing the network. This multi-layered approach ensures that even if one layer is breached, others remain intact. And here's why that matters. Continuous learning is the cornerstone of staying relevant in industrial automation. As the landscape evolves, so must your skills. Let me share a real-world example. John, a seasoned automation engineer, attended this year's conference. He told me, "Every year, I learn something new that I can apply directly to my projects." This year, it was advanced PLC programming techniques that cut my project time by 30%. This isn't just about keeping up, it's about leading the field. Workshops, seminars, and online courses are your tools. Make them your allies. The trick is to integrate this learning into your daily practice. This leads us to the next crucial point: community and collaboration. Engage with peers, share insights, and leverage collective knowledge. This isn't just about individual growth, it's about elevating the entire industry. Now, let's delve into common pitfalls you might encounter in PLC programming and debugging. One frequent issue is improper handling of data types. Always ensure that your variables are correctly defined and used consistently. Another common mistake is neglecting to properly comment your code. Comments are crucial for maintaining readability and understanding the logic behind your programming decisions. Additionally, be wary of timing issues. Incorrect timing can lead to erratic behavior in your automation systems. Make sure to thoroughly test your programs under various conditions to catch these issues early. Remember, the devil is often in the details, so pay close attention to small configurations and settings that can have a big impact on performance. To master PLC programming, remember these essential points. First, always start with a clear understanding of the problem you're solving. This clarity will guide your programming decisions. Second, leverage modern software tools with drag-and-drop functionalities to streamline your design process. Third, utilize simulation capabilities to test your programs in a virtual environment before real-world deployment. Fourth, embrace the integration of PLCs with the industrial Internet of Things for enhanced efficiency and real-time data analysis. Fifth, prioritize security by incorporating robust features such as encryption and secure communication protocols. Lastly, commit to continuous learning through workshops, seminars, and online courses to stay updated with the latest advancements. By following these key takeaways, you'll be well equipped to excel in PLC programming and contribute to the evolving landscape of industrial automation.